functions, transformations. In a cubic function, just like in our quadratic function, we're going to have 4 changes that can take place. So we can have a graph move vertically up or down the y-axis. We can have a graph move horizontally, left or right, parallel to the x-axis. We can have a graph reflected in the x or the y-axis, and the graph then can be stretched up or down. So in the first case, if we add or subtract a number to our function, then the graph will move vertically up or down the y-axis by that amount we have added to it. So in other words, if we have f of x plus a, then the graph moves up the y-axis by a units. If we subtract a number from the function, then the graph moves down the y-axis by a units. So in other words, if we were to look at this function here, the function is x cubed is equal to x cubed minus 2x squared plus 1. So if we were to look at f of x plus 1, well, that new function is x cubed minus 2x squared plus 1, so the original function, and then we add 1 to it. So what that basically means is that y is now equal to x cubed minus 2x squared plus 2 would be the new functional form. But of course, rather than plotting every single point for this graph again, we can see that if we actually just pick a point on our original graph, which is the green one here, and if I look at that point there, that point is out to 0 and up to 1. So if I basically look at my point 0, 1, x is 0 and y is 1. Well, what I'm actually doing here is I'm taking all of my output values and I'm adding 1 to it. In other words, I'm taking all of the y values and I'm adding 1 to it. So therefore, the point 0, 1 would be mapped onto the point 0, 2. So in other words, it would move up 1 unit on the y-axis. And I could do that with every other point on the graph. I could pick any point on the graph and I would find its corresponding y value by moving it up 1. So all of the x values would remain the same. It's only the y values that are going up by 1. Now, if I had f of x minus 1, well, what this would become is we would have the function minus 1. So that means that it would be the original function minus 1. So we would have a new function representing our new graph. But of course, again, rather than plotting each point, we could just take several key points on our graph, and we would see that if I take 1 away from it, all of my y values now go down by 1. So for example, if I just take 1 point there, so we had 0, 1. So the new point would be that I would subtract 1 from the y value. So that would become 0, 0. And you would set up several points and then move or transform each of your y values. So if we look at f of x plus or minus a, in other words, we're adding or subtracting a number to x, then what happens is our graph moves horizontally left if it is x plus a. If there is a number subtracted from x, then the graph actually moves horizontally right. So it's almost counterintuitive. So if we were to look at the graph here, then the blue graph is f of x is equal to x cubed. So we can see here, if I take this point, it's 0, 0. And I can see the graph has shifted to the left. So I can see 0, 0 has actually become 1, 2, minus 3, 0. So we have 0, 0 has become minus 3, 0. And therefore I can see that my x value has been reduced by 3. So in other words, I have taken 3 away from the x coordinate. So all my coordinates have shifted to the left by 3. So the actual new function, if we call it g of x, would be x plus 3. Okay? So when it's plus the graph moves to the left. But if I was looking at all my set of points, they are reducing by 3 for the x values. So say I pick another one there. So we go out to 1 and up to 1. That's now becoming out to minus 2 and up to 1. So we have 1, 1 becomes minus 2, 1. So again, my x and my y, the y is staying the same, but the x has had 3 taken away from it. If I was to shift the graph to the right, well then we would be adding 3 units to every coordinate on the graph, but the function would be written as, let's call it h of x, and say h of x would be x minus 4, say. So because I have a minus a there, well, what that means then is the graph moves right 4 units. So therefore we would be adding 4 to every x coordinate. And this is because if we have x minus 4 equal to 0, that becomes x equals 4. So in other words, the root is where it crosses the x-axis. We'd be adding 4 to it. So you could sketch maybe 3 or 4 points there and then sketch the new graph. So if I just mark 1, 2, 3, 4, 5 points on my original graph there. So this is f of x, this one's g of x. So we're going to do a little sketch of h of x. So if I look at my 5 points that I've picked from f of x there, I have out to 2 and up to 8. I have out to 1 and up to 1, out to 0, up to 0, out to minus 1 and down to 1, and out to minus 2 and down to minus 8. So therefore my new function h of x, I'm shifting it right 4 units, which means I'm going to add 4 to every x coordinate. So therefore 2, 4 would become 6, 8. So the y value is staying the same. 1, 1 would become 5, 1. 0, 0 would become 4, 0. Minus 1, 1 would become 3, 1. And minus 2, minus 8 would become 2, minus 8. So we can do our little sketch of our graph, and we can see we're getting exactly the same shape. But the whole graph has just been shifted to the right. When we're looking at multiplying the whole function by minus 1, then the graph is reflected in the x-axis. So in other words, the y value is multiplied by minus 1 and x stays the same. If the graph is reflected in the y-axis, then what happens is the x value is multiplied by minus 1 and the y value stays the same. So in other words, all the x values are multiplied by minus 1 and the graph gets reflected in the y-axis. All of the y coordinates are multiplied by minus 1 and the graph gets reflected in the x-axis. So again, we can see here, if we were to pick a couple of points on f of x, if we were to have out to 2 and up to 1, well, the 2 becomes a minus 2 and the y stays the same. 1, 1 obviously wouldn't help us much because that's going to stay the same, or 1, 0 I should say. And then if I had out to 2, sorry, I've done that wrong. If we're looking at the graph there, if I go out to 2 and up to 1, and then this value here is 2 minus 1, so my y coordinate has been multiplied by minus 1. Out to 0 and up to 1 becomes out to 0 and down to minus 1. So again, we're multiplying the y coordinate by minus 1. So out to minus 1 and up to 2 becomes out to minus 1 and down to minus 2. The same can be said over here. If I go out to 1 and up to 0, well, if I multiply by x by minus 1, that becomes out to minus 1 and up to 0. I can go out to 2 and up to 1 and multiply my x value by minus 1. That becomes out to minus 2 and up to 1. And I could pick one more point where I go out to 2.5 and up to 4. That would become out to minus 2.5 and up to 4. So again, by multiplying the x or the y coordinate for your series of coordinates on your original graph, you can then sketch your new graph. Or by being given the graph, you should be able to recognize, by looking at several points, what has happened to either the x or the y coordinate. So again, the last transformation, same as quadratics, is that we can either stretch our graph up or down by multiplying the function by a constant. So in other words, for every x value, the y value is the one that's going to be multiplied by this constant. So the x values will all stay the same, just the y values are going to change. So if a is a whole number and we're multiplying it by all of the y coordinates, the graph will get narrower as a increases. And if a is a fraction, then the graph will get wider as a increases. So here we can see the red graph is y equals x cubed. And if I look at the blue graph, it's equal to nx cubed. So n must be a whole number because the graph has now gotten closer to the y-axis, so it's getting narrower. So we have an example here from O.D. Morris's book, and we can see we have the first original function, y equals f of x, and we're told two of the points on the graph, it's 1, 2, and minus 2, minus 3. And then we're given four graphs, A, B, C, D, and we're asked which of them is showing y is equal to f of x plus 2 minus 1. So if I have y equals f of x plus 2 minus 1, that means there are two changes. So two transformations. So the first one is that if I have f of x plus 2, that means the graph is going to have shifted 2 units to the left. So in other words, the x coordinate minus 2. Okay? So if I look at my coordinate on the graph and I take, say for instance, 1, 2 and minus 2, minus 3, well, 1, 2, if it's shifted to the left, should now become 1 minus 2. In other words, it should become minus 1, 2. And minus 2, minus 3 should become minus 2, minus 2. So in other words, I'm subtracting 2 from the x coordinates. So that should become minus 4, minus 3. So that's my x coordinate, my y coordinate. So my y coordinate would be staying the same. However, there is another change, okay? And the other change is that we have taken the function and we have subtracted 1 from it. So it's f of the x minus 1. So in other words, whatever our function is, minus 1. So what this tells me is that the graph is going to move down the y-axis in other words, it's the y-coordinate minus 1. So I've already made my shifting to the left adjustment, so I now need to take these new points, minus 1, 2, and minus 4, minus 3. And if I now adjust the y-coordinate, which should be minus 1, then that's going to become minus 1 and 2 minus 1, which is going to become minus 1, 1. And then minus 4, minus 3, minus 4, minus 3, minus 1, which would become minus 4, minus 4. So I have two changes, and the order in which I make my changes doesn't matter really. as long as I'm always taking the new coordinates. So it's a bit like your input, output. Okay, so what adjustment have I made? And then write down your coordinates. So now we look and we see, can we identify a graph with -1, 1 on it, and -4, -4 on it? And we can clearly see that it's graph D. So we say, therefore, this function is D. So in this example here, still from O.D. Morris, we can see that we're actually not given any points on our graph. So we kind of really are looking for what changes have been made here. So again, I can see there are 2 changes that have been made. Because it's y is equal to -2 minus f of x. So if I look first of all at minus f of x, that change means then that I have multiplied all the y coordinates by -1. In other words, the graph is reflected in the x-axis. So in other words, if it's reflected in the x-axis, it's going to end upside down. Okay? And therefore, you would kind of say, well, that eliminates then C and D, because if I look, one of my points is sitting on the y-axis. The highest point is sitting on the y-axis, above the y-axis. So if I was to take the y-coordinate there and multiply it by -1, it should end up on the y-axis. So I can see that in A and B. So now I have to look at what's the second change to eliminate which one we have, because again, the second point is also sitting on the x-axis. Okay, so clearly some other change has to have been made, because neither of these have the lowest point sitting on the x-axis. Okay, so there has to have been some other shift. So our second change then is that we have the function -2. So that means if we have the function -2, that means all of the y values now have -2 taken away from them as well. So in other words, the graph moves down the y-axis by 2 units. So in other words, we're taking -2 away from the y-coordinate. So clearly that eliminates B then, because if I was to turn the graph upside down, whatever this point was, say it was -2, 0, right? Then if that point was -2, 0, and I was to multiply it by -1, it would still be -2, 0. So in other words, it still would be sitting here on the x-axis. But now if I look, I can see in B, that point has moved up, so I've added something to the y value, whereas this point has moved down, which means I've taken something away from the y value. And I need to be subtracting 2 from each of the y values, so therefore it has to be A. So it's by the process of elimination. In this case, we would say, therefore, y equals -2 minus f of x is the function A. Or is graph A, I should say. Okay, so let's go to our books. So on page 146, you're going to do question 4 to 9.